Well, I have a question for Frank. Um, what do you do uh, with um, the two types of inefficacy? Um, just inefficacy where you don't find a difference between A and B, and then the other type where you find something is harmful. And are there ways to define degrees of inefficacy?
Well, you'll get a posterior distribution for the amount of efficacy, and that sort of tells all. But I think it's not so helpful to try to split the difference between a trivial benefit and harm. You might want a formal analysis that it's actually harm, but what we really care about is there's either harm or a completely trivial benefit, which makes the futility analysis very expeditious and uh, makes you stop much earlier. I don't know if that answers your question, but it's just one take on it.
Well, so let me ask it a slightly different way. Um, in the group that you stop, um, there there must have been on the um, MCID um, some loss of MCID, some negative MCIDs. How often does that occur? And are there rules to identify that part of the Bayesian inference?
If I understand the question, I don't think it's something you would want to spend a lot of time on unless you're doing a crossover study. So a crossover study will allow you to interpret individual patients' outcomes. But if you're doing a parallel group study like a blood pressure trial, you're going to see 30% of your patients raise their blood pressure, even though you have a lot of evidence that blood pressure is lowered. So it's not that fruitful to me to look at it individually like that in a non-crossover study.
Okay. Um, I'm thinking about um, in a stroke study with a non-continuous measure, with an ordinal measure that perhaps lacks some precision, where you see a worsening of the ordinal outcome in one of the two groups. Um,
Yeah, the idea of
what
worsening is not,
informativeness do you give to that finding?
I think the idea of worsening is not well defined outside of a crossover study. So I wouldn't look at worsening in the way that I think I understand you asking it.
Okay.
There's a lot of regression to the mean, measurement error, things
Mm,
that make you think something's worsening, but it's just noise.
okay. I'll try one more. Um, why is it um, that most of our guidelines um, and most of the FDA determinations are for phase 3 trials are currently based on frequentist designs? What is attractive about those?
I'll give you the short answer. The short answer is Fisher traveled the world spreading his gospel, and he had a lot of students. Bayes died before anyone knew what he had done. He had no students, he didn't travel anywhere. And then the methods that he created, which are really perfected by Laplace, required computational abilities that nobody had until about 20 years ago. And so you had all this late to the party effect because of needing computations, whereas Fisher could calculate a p-value on the back of a napkin by hand. And so a lot of it was computational solutions were needed that weren't really freely available till about 20 years ago. And then there's just plain inertia. And when I talk to people that are out of graduate school, most people have not had any Bayesian courses. that's a real problem. That's not going to fix anything. And then I ask them, do you want to learn Bayes? They say, well, I'm kind of busy right now. So there's a laziness to learn new stuff. And I don't understand that because if I'm not learning something new every single day, I get sleepy.
That's a good characteristic for a human being.
Josh and I do mention Bayes in our course that we teach to clinicians. We do still teach frequentist because that's easier, but we do mention Bayes.
Good, good.
Okay.
Let's see. Oh, going back to marginal estimates, estimates. Before even the question that just appeared, there was this question earlier about conditional versus marginal effects. Can we try to answer that? So the question was, the presentation that Michael showed us essentially focuses on marginal average treatment effects. And then what we get from simple adjustment using regression model, that's essentially conditional treatment effect. And so the question was, well, first of all, it was, is there a difference? Can we get marginal effect from the regression? But then, what are these different packages doing, standard packages that people usually use? I don't know, Josh, is that question for you or for others?
Oh, which question is this?
It's the last one that's in the question and answer.
Okay, let me have a look real
Actually,
quick.
this is slightly different, but it was, maybe we should just go to this one. I think I'm confusing everybody.
Ronan's question?
Yeah, do that first, and then Guyan has a variation on that.
Yep.
So if you have a conditional treatment effect, you're targeting a different statistical quantity than the marginal. And so the methods that we proposed are for when you want to look at the population average treatment effect versus, the treatment effect within strata of covariates. The methods that we use are meant to be robust to arbitrary model misspecification, or doubly robust for those that are familiar with that terminology. So the advantages of those things are we're not imposing additional assumptions about that a model is correctly specified, and that we may have the same or even weaker assumptions than the unadjusted analysis. But as to why you would choose a marginal versus a conditional effect, it kind of depends on what is the actual question. What do you want to actually learn about? And that's going to drive your choice and estimate. Are you trying to learn what's going to happen in the population as a whole, or are you trying to learn about the treatment effect within strata? So those are two different targets of statistical inference. Does that address the question?
Yeah, that's what I was going to ask. Ron, does that address your question?
It'll be easier just to speak. I feel like I'm joining the panel. It doesn't feel fair. But I suppose my point is more, covariate adjustment, one of the primary reasons why it's talked about in your talk or Michael's talk was it increases power. And I think the point is more a technical point, which I think for the proportions case for logistic model, assume the odds ratio. For the marginal effect, it seems like the increased power is still due to increased precision. But I think for the conditional treatment effect from a standard logistic model, it actually doesn't increase the precision, but it leads to less underestimation of the true treatment effect. So it's a slightly different mechanism of action for why a covariate adjustment is important for a standard logistic model, standard quote unquote. So it's just, I think from an educational point of view, the marginal statistic seems to have a marginal estimate, seems to have the advantage that it's all ANCOVA-like basically. So if you're trying to communicate why the powers increase, it's the same for all these endpoints and all these statistics, rather than if you're using the conditional model, which is implicitly what most people are using, which was my point earlier on. If you're just putting it to GLM mix or something like that, or proc mix or whatever, where it's a bit more obscure when you get into the technical detail.
Great. I think it's a good point. Kelly, it was very impressive to see the number of different problems that smart designs are being used on. And you briefly brought up, but I'd like your thoughts on vascular diseases have some qualities where some of the endpoints are abrupt and severe, and they're not always continuous. And they have longer times to understand the impact of those events. Have you seen the smart design applied to vascular disease or other situations that are encountered in critical care, like the ones that John Casey described?
I can't think of one off the top of my head, but that doesn't mean that it doesn't exist. I would say that you do have to be careful in a smart design about absorbing endpoints and how those are handled. If that's the case where individuals may die before second stage, right, that has to be really carefully considered in the design and analysis, and is unlikely, I think, to be used in those settings. This design is unlikely to be used in those settings.
Because they have some stepwise progressions as opposed to continuous progressions, and some of the stepwise progressions include death.
Yeah, that's not to say that I don't think it ever could be applicable, but I'm not sure it's really been fully developed in that space yet.
Yeah. But yeah, I think you did take up the case of platforms where you reject that a particular treatment is valuable, and you use those events to go on to a different set of treatments.
Yeah, absolutely. Absolutely.
So in the kinds of disease situations I'm describing, that might be a use for it. Okay. Do we have any other questions?
Doesn't seem like.
Well, we still have a number of people who've hung on. I think we'd like to thank everybody, particularly thank the speakers. From my perspective, but I'm a little bit more like John, I'm just a trial person. It was each talk was better than the other, and
Wow.
there's a lot of interaction between them, and I want to thank the speakers for their effort. Diane, I'll give
And
you the last say before we turn it over to
oh,
Cecilia.
I'll just add my thank yous to Diane's and just say thank you for the presentation, for sharing the resources, which I think would be very, very useful to everyone. So yeah, it's been an amazing couple hours that just flew by. Thank you very much.